Alright guys, we are going to do notes on F.1 from the sequences test. So if you need to remediate and retake F.1 from test 1, you should be watching this video. As I go along, go ahead and take notes on your sheet, and then at the end, you're going to correct your test question that went over F.1. So we're going to compare properties of two functions, each represented in a different way, sometimes algebraically, sometimes graphically, numerically in tables, or by verbal description. So in this example below, we're actually going to go ahead and look at two different sequences graphed on the same grid. So you can see sequence A is highlighted with the blue dots, and then sequence B is the black dots. So on your paper, the blue is probably just a little bit like gray, and the sequence B is represented by the darker black dots. So if we look at sequence A, can you describe a way to produce the new term from the previous term? So what are the terms? Let's go ahead and fill out this table. So for sequence A, the first term is the y value right here. So the first term is 2. The second term is 5. And then we have 8. And then 11, 14, and then 17. Let's go ahead and copy down the table for B as well. So the first term, again, the first term is here. So when the n or the term number is 1, we start at 1. The second term is 2. I'm looking at this dot right here. The third term is 4. The fourth term is 8. The fifth term is 16. And then even though you cannot see the sixth term on this graph, hopefully you see the rule and you can see that the sixth term for the sequence B will be 32. So then we're going to answer these questions to the right. Describe a way to produce a new term from the previous term. So for sequence A, what's happening from term to term? What are we doing from 2 to get to 5? From 5 to get to 8? From 8 to get to 11? Hopefully you see that we're adding 3 to each previous term, or to the previous term. So when we're adding a constant to the previous term, that will produce an arithmetic sequence. So this one is arithmetic because you're adding a constant every time. And then it wants us to write a formula to find the nth term of sequence A. So remember our formulas for the nth term will be A of n is the 0 term plus the common difference times n, or if you start with the first term, it'll be the first term plus the common difference times n minus 1. Excuse me. So we're going to compare sequence A. I'm going to go ahead and use this one because in the table we have A sub 1. We have the A of 1, the first term. So what's our first term from the table or the graph? Do you see that the first term is 2? So I'm going to fill out that formula. A of n is equal to, the first term is 2. What are we adding every time? That will be your D, or the common difference. We're adding 3 each time. And then if we start with the first term, we'll multiply that by n minus 1. So there's the sequence, the nth formula. Hopefully this makes sense. This just means that you could replace this n value with anything in the table and you should produce the sequence A that you have written down. So let's try one. Let's plug in 3. We should get 8 when we plug this in. If not, then we didn't write the right formula. So 2 plus 3 times, I'm going to do the third term, so n is 3 minus 1. So let's do the math there. That'll be 2 plus 3. 3 minus 1 is 2. 3 times 2 is 6, plus 2 is 8. So you can see you have an 8 there. You could try another one and it should continue to work and produce the sequence for sequence A. Now let's look at sequence B. How can you produce a new term from the previous term? So what operation or what are you doing with 1 to get to 2 to get to 4 to get to 8? Hopefully you were thinking we're doubling or we're multiplying the previous term by 2. So when we're multiplying by a constant, we're multiplying by 2 every time. That means it'll be a geometric sequence. And then the last thing we'll do again is write the nth term of sequence B. So we're looking at geometric. So I'll write the formulas below here. The nth term will be the 0 term times r to the n. Or if you start with the first term, it'll be the first term times r to the n minus 1. Remember, r is just what you're multiplying by every time. And then this notation is just the 0 term or the first term. Okay, so a of n equals, I'm going to again start with the first term because I have that listed in the table over here. The first term in sequence B is 1. So I have a 1 times, we usually put r in parentheses just to be safe. If that's a negative or a fraction, it has to be in parentheses. So if it's if you just want to go ahead and put it in parentheses every time, then you don't have to worry about when to use parentheses. The r, what is our common ratio here, guys? We are multiplying by 2 every time. So the common ratio is 2. And then if I start with the first term, then my exponent is an n minus 1. Remember that n minus 1 in geometric is an exponent because remember this looks like an exponential graph if you look at the graph. Okay, now I would like you to go ahead and go to your test and correct the questions that you missed for the standard F.1. Those questions on your test will be, it's just question 7. So correct question 7 and then check in with your teacher for the retake. Thank you.